to your contacts, students groups?
Sir,
Yeah.
what I feel is today you don't share it.
Okay. No problem. Yeah. Tomorrow
Maybe
then.
after
Yeah.
the
Yeah.
session, if someone
Session
has
and
missed, then you
maybe some
can.
editing is required there.
Not required editing also, but it's better that you share it after the
Yeah.
session because
Okay.
right
Okay.
now you're doing it for the registered participants.
Yes. Yes. Okay.
So, yeah, it started. You may start.
Yeah. So.
So it's almost 6:36. We can start.
Okay. We shall start. We will start. So, hello and good evening, everyone. On the behalf of IAPT Sub-Regional Council Pune, SRC Pune, I am I do welcome all the students, the speakers, the participants, my fellow teachers, and everyone. That this particular series we have named it as a online boot camp. So let's prepare with precision. The meaning of boot camp is an intensive training or a crash course. So it will make the students, those who are aspiring to get a good score in the National Graduate Physics Examination, we are helping them by organizing this type of activity for the second time. Earlier, 3 years before, we had such attempt, but this time in between 2 years, because of some reasons, we couldn't go for that. But this year we have prepared. One more thing is very important. I want to share with you all. These days, almost all teachers in Pune, Mumbai, etc., these are busy in election duties. So it was very difficult for me to organize this particular session to convince the people and get them ready for the preparation and for the sessions. But somehow I could get the 6 different persons from different regions, those who have agreed to participate in this particular today's session. One more very important thing I would like to share, that Central IAPT is very positive in this concern. They have provided every support. This entire technical support is being provided by Gorpade ma'am and Dr. Ahluwalia sir. Those who are very proactive and very positive in all this type of activities which are being conducted online or offline. Along with that, all my colleagues in the IAPT SRC, our president Hawaldar ma'am, our secretary Dr. Shashikant Shinde sir, and all other our executive members, they were very positive in organizing all this particular activity. Especially, it has been found that in the last few years, the registration from Maharashtra is declining. Actually, number of students, those who are opting for the physics special, is declining, and because of that, the number of students, those who are appearing for this type of NGP examination, this number is also declining, and the representation of Maharashtra is on the reverse side. That means it is decreasing day by day. Not to happen that, or to boost the confidence of students, we have planned in our earlier meeting, we should go for this type of online crash course, which will help mostly students from Maharashtra and other regions too. So in this endeavor, we have been supported by all the IAPT members, as well as the central IAPT office bearers and all my colleagues. So once again, I welcome you all on this particular event. And I'd like to ask Dr. Rekha ma'am just to say a few words about this activity. Then I'll introduce the speaker, and then our session will start. Rekha ma'am.
Yeah, thank you, sir. Thank you, and a very warm welcome on behalf of IAPT and on my personal behalf to each one of you. I'm very happy to, start this particular program of by Pune Savarsi. I think this is a very important event that is taking place right now. First of all, students probably, since they have joined, they are convinced that National Graduate Physics Examination, which is conducted by IAPT, is a very important examination as far as the standardization process is concerned. Now, what is standardization? Because the education in the country is not really standardized, and each university is following a different syllabus, And whenever it comes to appearing for some competitive exams, which are the joint entrance examinations or say IITs or other GATE or other entrance examinations, the students are really left confused because the examination patterns by the various universities are different, and which the entrance examinations demand something else, which is a conceptual understanding probably. And therefore, our visionaries like Professor R.N. Kapoor, Professor Dharkar, Professor Srinivasan, and of course, Professor Khandelwal, these people have thought that the education in the country should be standardized at both +2 as well as the UG level. And for +2, we have started national standard examinations much before, 10 years before, when it was not a qualifying examinations for Olympiads. And for UG, we have started National Graduate Physics Examination, that is NGPE. NGP allows the students to judge themselves against the national standards, and therefore they really are able to find out the weaknesses, and they can work on their weaknesses, and they also get a direction how to start studying or start thinking, and what should be the conceptual understanding by solving the problems, because conventional question papers demand only a mugging up process where you just mug up something and then reproduce it during the examinations. And even if you solve few years question papers, I think the students are able to succeed in their university examinations. But for the entrance examinations, competitive examination, it is not so. It requires a lot of conceptual understanding, and that is the reason why we have started this NGP. All these years, I think it is almost more than 25 years. If you look at the earlier question papers, the questions are set, they are very of high standards. And at the outset, the students might feel that, oh, this is not my cup of tea. But when they try to solve or take up just one question and then work on it for a week or so, I think they will understand how important it is to learn the concept. And this is one success. And all our students up till now who have qualified for NGP pattern, I suppose many of you must be aware that the students take up NGP, that is at the part A and part B level, which is generally conducted in the month of January, the third Sunday of the January. And the top 25 selected are called for a workshop, which is an experimental workshop, and some tests are conducted during that workshop. From this test, the top 5 are selected for the gold medal. And these top 5 students have a red carpet entry to many of the research institutes also. They also get good scholarships if they pursue the higher education in physics itself. So I think you really have a greater exposure than what you have right now, and it's a very wonderful platform to really have the insight for the physics education also. So for that matter, I really appreciate the program organized by Pune Sub-Regional Council 08C. I wish them all the grand success, and I'm sure the students are really going to have a fruitful time. I also thank all the resource persons for taking out their valuable time and thinking of solving questions with students and guiding them. So thank you very much on behalf of IAPT also. Let us have wonderful time. Next, all the sessions, the 6 sessions which you have organized, will be a very, very great sessions, I'm sure. So wish you all the best. And thank you, sir, for giving me the opportunity to talk.
Okay, thank you, ma'am. Now I will introduce the today's speaker, Dr. Sri Krishna Shivaji Gaikwad. He is currently a faculty member of physics at the Department of Physics, Nauroji Wadia College, Pune, and he has been teaching there since 2015. So that means he's having a teaching experience of almost more than 10 years. He has completed his PhD in physics from Savitribai Phule Pune University. He has international research experience having conducted research for 4 years from 2011 to 2015 at the National Dong Hua University in Taiwan. He has published 8 research papers in reputed journals, including scientific reports and like JMMC, APL materials, and so many other important journals. He has participated in more than 15 conferences, international and national conferences, workshops, and attended a faculty induction program at ISER Pune. He serves as a visiting faculty for IDSS, Interdisciplinary Science Studies Center at Savitribai Phule Pune University, Pune. In his academics, he secured the second rank in TYBC physics in 2006 and scored almost 93.007% in the GEST examination in March 2010. He was awarded the NDHU scholarship for international students from February 2011 to February 2015. He played an active role in the implementation of the National Education Policy, contributing to 5 BOS and Academic Council meetings in his department. He holds a MSc in physics grade from MSc in physics from the Savitribai Phule Pune University, and at his BSc he received obtained distinction, and he was the second rank from one of the college from the Baramati, and also he's qualified the state examination 2010 with merits. So such a distinguished speaker we have with us today, and I hope he will be very comfortable with all our students and staff members. I am expecting him today. He will go for some basic problems and issues or the concepts in the mathematical methods of physics, which is one of the very integral part of our syllabus and the entire NGPE examination. So I welcome once again the today's speaker, Dr. Sri Krishna Gaikwad sir, and I request him to deliver his session just now. Thank you. Thank you. Over to you, sir.
Thank you very much, sir, for introducing me. So directly I start with the presentation.
Yeah.
Okay. So as a part of this NGPE examination, there are various subjects from the physics, and on that we will be used to get the different question paper questions. That is something like some problems related to the mathematical methods in physics, electronics, quantum mechanics, and so forth. Means the various different branches of the physics. Here we can find the different problems. One of the most important subject of the physics is mathematical methods in physics. Some part of that is also covered in the mathematics as a core subjects generally we used to have in a undergraduate level. Okay, so this examination is particularly for the undergraduate level students. I am going to talk about the some problems from the mathematical methods in physics. So the first problem, these problems are actually from the already asked in the NGPE previous examinations. So I will just go through the some basic idea and the how to solve these problems. Okay, so the first question is the scalar triple product of the three coplanar vectors is 0. So here we have to whether defend the question or we have to refute it. You can deny the answer, but whatever the question is given. Okay, so particularly all the physical quantities are classified into the scalars and vectors. Okay, so the scalars have only magnitude, vectors have the magnitude as well as the direction is required to its a complete understanding. Okay, so the scalars generally represents with the numbers. Okay, but the vectors are represented with the three different kind of the directions, and their respective directions unit vectors are from the for the x-axis, y-axis, and z-axis are represented as I cap, J cap, and K cap. These are the unit vectors along the X, Y, and Z axis. Okay. So here, when we represent the any vector that is A bar, it will be having the components as AX I cap plus AY J cap plus AZ K cap. Okay, hope this you can see it clearly. And another vector, if I want to just represent with the its component as a Bx I cap plus By J cap plus Bz K cap. Now, similarly, we can have the n number of the vectors, but here we can have the dot product and the cross product. Just like the scalars, we can multiply each other and we can get the
Gaikwad
numerical
sir,
value.
sorry to disturb you.
Yes, yes.
Your script is not visible and it is inverted. Can you please share the script
It is inverted.
screen to everyone?
Sir, actually,
Is
what
it
is
fine?
needed is he can stop sharing if you are sharing this blank sheet. Scalar triple product 3 coplanar is 0. And
Yes.
just show your, because you are
Okay.
directly, I think, connected.
Okay,
So
so
your
I share
profile.
my the mobile
Mobile, yes.
camera.
Please share your
Okay.
mobile
Yes.
screen and you can hide your slides.
All right. Okay.
And it would be better if you turn it by 90 degree because it's inverted still 90 degree angle.
90 degree angle.
Again.
Okay, if I rotate it again, it goes like this.
Other direction, is it possible to rotate?
Oh,
90 degrees in the right side, right hand side. Clockwise.
Probably this was.
No, it is reversed actually.
No, sir,
Sir.
no.
180 degree reversed.
Exactly opposite.
Exactly opposite.
Exactly opposite. One minute.
Still not.
Now it's fine.
No, sir, it's now exactly opposite.
Exactly opposite.
The previous one. No, sir, no.
180 degrees.
I think you just change the direction of your mobile screen or mobile, then it will be correct one.
Okay, now I change the direction.
Yes. Now it's correct. Yeah, it's correct.
Now it's correct.
Yeah.
All right. Yeah. Because that will have the less area will be covered. Okay, hope this works now.
Yeah, that's correct. Okay, you can go ahead. Continue. Please continue.
All right. So we can have these vectors representation as a bar and B bar. Okay. So I can have the multiplication of these vectors as a dot product and the cross product. So I can represent its dot product or the scalar product as a bar dot B bar is equal to AB cos theta. Similarly, we can have the cross product as a bar cross B bar is equal to A bar, so A into B into sine theta into n cap. N cap, it is the unit vector along the vector formed by the two vectors A bar cross B bar. So this is how we can represent the vectors or its multiplication. Okay, so if we want to have the multiplication of the three vectors, again we can have the cross means vector product or the scalar product. The scalar product of the three vectors can be represented as a bar dot b bar cross c bar. So the dot product of the a bar vector with the plane formed by the b bar cross c bar. So we can have these are the two vectors a b bar and the c bar. So whatever the plane it has formed, we can have the perpendicular direction to here is cross product is represented as a b bar cross c bar. So this is the means this is the plane form, and we can have the perpendicular to this plane is given by the b bar cross c bar. So ultimately we are getting the one more vector which is the form by the b bar cross c bar. So we have to again take the product with the another vector as a bar. So it is forming like a three-dimensional structure. So here again we can have the two types of the products, that is the scalar product and the vector product. We can take the scalar product with this vector as a bar dot b bar cross c bar, and the cross product ultimately will go to the a bar cross b bar cross c bar. So if we want to represent the this vector according to our the question, that is the scalar triple product of the uh, three coplanar vectors. Means coplanar means they must lie within the same plane. Means we can represent the any one of the vector as a linear combination of the other two vectors. So I can represent my vector c bar as linear combination of the remaining two vectors. So I can represent the c bar is equal to alpha a bar plus beta b bar. Okay, so I have to just substitute this vector into the given scalar vector formula. So what I can have the a bar dot b bar. Now C bar will be replaced with this the so I just replaced the symbols with the A bar and the capital one. Okay, so B bar cross. Now we can have this combination as alpha A bar plus beta B bar, and we can have the multiplication inside it, and we will get it something like A bar dot B bar cross alpha into A bar plus B bar into into beta B bar. Okay, so this is what the result we get it. Now just try to solve it further. So I can have this is a bar dot B bar. So alpha I take out 1 minute. A bar dot alpha I can have the B bar cross B bar, and sorry B bar cross A bar and plus beta, and we will be having the B bar cross B bar. So as we can see from the this direction, so having the B bar cross B bar will give us the 0. So the angle between the any vector with itself is a 0. So sine theta becomes a 0. So this vector becomes a this part becomes a 0. So now remaining is nothing but the A bar dot alpha into B bar cross A bar. Alpha is a constant, so I take out this, and A bar dot B bar cross A bar. Now, in case of the scalar triple product, it is a cyclic coordinate. If I rotate, then there is no change of its sign. So alpha into, if I just rotate it cyclic with the coordinates, then I can have the B bar into A bar cross A bar. So this will give rise to the A bar cross A bar again goes to the 0. So ultimately we will get the uh, its answer is a 0. So we have shown that the scalar triple product of the three coplanar vectors is always a 0. So we can answer this question as a we defend the question. Okay. So the next question is related to the again the differentiation of the vector quantities. Okay, suppose we have the function f is equal to phi is defined as a 3x square plus y raised to 4 6x square z square. Now what is given, that is the divergence of grad phi is supposed to have the del bar dot del phi is how much. So the it is being asked that okay, del bar dot del phi is equal to how much. So what is the del operator, particularly gradient operator? This is in the 3-dimension case. So we can have the partial derivative of the each variables along the respective axes. So I just define the del bar is equal to I cap dabba by dabba x, j cap dabba by dabba y plus k cap dabba by dabba z. So if I just multiply with the any function with it, so I can have the del bar phi is equal to I cap and dabba by dabba x, and this whole function I have to write down here. So I just avoid the multiple steps and write down here. So y raised to 4 plus 6 x square z square. So what is the ultimately the derivative of this dabba by dabba x? We have to consider the other variables to be the constant one and the take its derivative to be 0. Only the differentiation of the that whole function with the x only. So similarly we can write down for the j cap and the plus k cap as well. Okay, derivative of the corresponding to it. So what is the derivative here? We get it, that is 6x. Now y will be treated as a constant, so that will give rise to 0 differentiation. And here again we have that another term as the x square, so its derivative is 2x. So 6 into 2 is 12x z square. Now this is the one of the component of the vector, I got it, of the del vector. If I take the again further the del phi of it, so I can have the gradient of the this del phi, and I could get it the nothing but the I dabba by dabba x into I would be having this I cap into 6x plus 12x x z square. So the dot product with itself will give us the one more product, and that will come out to be the I cap dot I cap is 1. So the derivative of this whole function is the 1 plus 12 z square, because the derivative of the x is 1. So the I got the answer as a 12 z square. Plus similarly, if I just try to solve for the other components, so the result will be coming as del dot del phi is nothing but the 6 plus 12 r square. Now here this how the r square has arisen, because there is always a radial component in the 3-dimensional case is given as a r square is equal to x square plus y square plus z square. So the answer for this question is nothing but the 6 plus 12 r square. So this is one of the again important problem from the previous exam. Actually, it was asked in the in 2022. Okay. Now, for further, we can have the one more question related to the. It is nothing but the del bar dot r into del phi is 1 by r3, and it is equal to how much? So any guesses for it? Has anyone solved? Yeah, this is again representing the r in terms because the in terms of the Cartesian coordinates x, y, z, or else we can directly write down its answer using the radial components, radial component of it. So it's particularly if we just go with the Cartesian coordinates, that is r square is equal to x square plus y square plus z square. Okay, so I can just try to solve this further. That is del phi of the r cube. So I just take the derivative of this I cap and dabba by the first component, and remaining will be the similar kind. So I can avoid that 1 over then x square plus y square plus z square is r, and its cube so is r square, so I can have the 3 by 2. So I just rewrite it as derivative of this is with respect to the x, so I cap into minus 3 by 2, and its derivative as x square plus y square plus z square, and now minus 3 by 2 minus 1, that becomes minus 5 by 2, and derivative of this term as a 2x, so this 2 will get cancelled out, and we can have the I cap into minus 3x divided by r raised to 5. Similarly, yeah, I sorry, if I can just multiply this with the r, because here we require the multiplication. So del bar dot 1 by r cube is equal to, so just multiply with the r. So this r cross, this is not the cross product in the vector, it's just the multiplication. 1 by r cube is equal to I cap, and the r will get cancelled out, so minus 3x upon r raised to 4. Okay, and again I have to take the derivative of it by using the del operator. So just operate the del operator over it, means the first component of it is nothing but the I cap dabba by dabba x, and this I cap will get cancelled with 8, so I can have the minus 3x upon r raised to 4. And if I just further solve this, I can get the component as the 3 by r raised to 4, because the one of the r will get cancelled with the this derivative, and will remain with the component as a 3 by r raised to 4. So similar kind of the problems can be asked in your next examination as well. Okay, so there is a one more problem related to it, but I'm just going to read for you. If suppose we have the function f of r, which is a scalar function of the position r, okay, and the expression for the we have to find out for the del cross of f of r into r cap, where r cap is the unit vector along the its radial part. So here we can have uh, this del of of f of r is a radial part, na? So we can take the derivative in the spherical polar coordinates as well. So del by f by df by dr into r cap, and just we can have the another expression, that is del f of r cross r cap. We can have this df by dr into r cap cross r cap. Okay, and this will be further giving us rise to the r cap plus r cap will give us the 0. Okay, so the cross product of the any vector with itself is 0. So we can have the del of f of r into r cap will give rise to the 0. So this is its conclusion, because there are other kind of the options are available, that is a +1, -1, 0, and the whether we have the known form of the function, that is f of r, can give rise to the complete answer. So the correct answer is the 0. Now there is a next problem, that is given as if suppose we have the dabba a bar by dabba t, or the d by dt of the a bar is equal to omega cross a bar, and we can have the db by dt is equal to omega cross b bar. Then we have to show that, think about the d by dt of a bar cross b bar is equal to omega cross a bar cross b bar. Okay, so ultimately we have to find out this. What is the multiplication rule for the derivative in case of the vectors? We have to apply here on the left hand side, and we have to show it to the right hand side. So this is the answer, that is d by dt of the a bar and the cross product of this with the b bar, plus we can have a bar cross d bar by dt a bar cross d bar by dt into b bar. Okay, so this is left hand side derivative are just imposed, and what is given condition here, that is the d a bar by dt uh, is given as omega cross a bar. So we can have the omega cross a bar cross, now this remained is b bar, plus a bar cross, now db bar by dt given is omega cross b bar. Here we cannot apply the like a cyclic coordinate rule, because the in cross products the vectors are not in cyclic rotation. So uh, even if we change the two vectors, their positions, their sign will get reversed. So if we apply that rule, this automatically goes to the 0, because if I just cross so change the position of the a bar cross omega cross, that will give us the minus omega cross a bar cross b bar, and this will get cancelled out with the 0, and probably what is being asked to show, we will not able to get the result. So for that case, we have to use back cab rule. Back cab rule, this is a well-known rule in case of the vectors, so we have to use the vectors accordingly. Okay, so I just rewrite them. by using this back cab rule. In the first place, we can have this as back cab now. So B is the first. So A bar dot omega cross, omega dot B bar minus cab. What is cab? Here for the first case, that is omega. I just take omega into A bar dot B bar. Similarly, I just apply the other rule, that is omega into A bar dot B bar minus B bar dot omega cross A bar. So this term A bar dot B bar into omega, and this negative sign of the omega A bar dot B bar, they will get cancelled out, and what is remaining is the A bar dot omega cross B bar minus B bar omega dot A bar. And if we reverse our back cab rule, then that will give rise to the omega cross A bar cross B bar. So this is what the our proof. So we can have the proof regarding that is hence proved the given. Okay. So now the next problem is the related to the again del dot of r cap. Generally we used to have the del bar dot r bar is 3, but if suppose we can have the del bar dot r cap. Okay, so the r cap is nothing but the, what is the answer for it? Okay, what is r cap? That is the unit vector about the radial divided its is magnitude. R bar can be written as x I cap plus y j cap plus z k cap. So this is the radius factor in the Cartesian coordinate, and its magnitude is given as root of x square plus y square plus z square. So the what we can have the dot product of this, dot product of the this actually. So r bar by r. So here dabba by dabba x into r bar is the x by r. I would just write down dabba by dabba y by r plus dabba by dabba z by r. Here we have to use the u by v rule. So I just use the u by v rule. The r as it is, derivative of the x with respect to x is 1 minus we can have this x as it is, and the derivative of this what is the derivative of the r with respect to x? R is nothing but the root of x square plus y square plus z square, and derivative of it with respect to is 1 over 2 and the root thing, and the derivative of within the root factor is the 2x. So 2x will get cancelled out, and this parameter remains as r. So x by r, I can have this r divided by r square. Similarly, I can get the another result as r minus y by r upon r square plus z minus r minus z by r upon r square. So 1 by r square is common thing. What is remaining is the r minus x by r plus r minus y by r. And 1 minute, I just made the mistake. That is x I was missing. So x is here, y will be there, and here will be the z. So we can have the x square, y square, then and z square by r. Yeah, my apology here. So because there is a x is present as a u into v, na? So the u remain there. So I can have this is 1 by r square, and remaining is nothing but the r minus, this is x square, x square plus y square plus z square upon r. So ultimately I get here result as a 1 by r square and 2 r minus r square by, and this is ultimately 1 by r square. Yeah, so this is r square, x minus y square by r. So this will give rise to the r square or r cube. So ultimately this will give rise to the 0 answer. Okay, so del dot of the r cap will give rise to the 0 answer. Probably the answer is what? Okay, yeah. So somewhere I made the mistake. Just x.
Yes, sir. Yes, sir. In taking the root of square root of differentiation of square root
Okay,
of
yeah.
x square plus y
Answer
square plus r
probably
square,
just check.
that should be
This
r.
is probably the 2 by r as answer. Yeah. All right.
Sir,
So I just carry forward.
r
I will just use the particular solution for that. Now I want to just ask the okay, where it is? Hello, can you hear?
yes, yes. Uh, you have taken
Okay. So
differentiation of
then
square root.
next thing is that okay. What are the infinitesimal volume elements in case of the different coordinate system, like a spherical coordinate system or cylindrical coordinate system, like that? My voice is lagging, I guess. Hello.
Yes, sir. Yes, sir. Please continue.
So we can hear you, no problem.
Sir, can you hear?
Yes, yes. Sure. We are. We are. Hello.
Can you hear,
Sir,
sir?
you can proceed. You can proceed. We can hear
Yes,
you.
yes.
Okay, okay, sir.
You
Yeah,
can
thank you.
proceed.
Okay, so infinitesimal volume element in case of the spherical coordinate is nothing but the r square sine theta dr d theta and d phi. This is in case of the spherical coordinate system. Spherical coordinate. In case of the cylindrical coordinate system, we d tau is represented as a phi ds d phi and ds. ds is nothing but the uh, sorry, this is the d2 s ds d phi and dz is the volume element in case of the cylindrical coordinate system. Okay, so this is one of the question which is being asked in case of the 2020 examination. So sometimes we actually neglect some easy concepts, so we miss the some marks there. Okay, the another concept is a very important and frequently asked in the this NGPE exam, that is nothing but the Fourier series. Okay, is one of the very important topic and very favorite for the NGPE. Actually, there are certain conditions of whether the given function is can be expressed as a Fourier expansion. There are some certain conditions known as the Dirichlet conditions. Dirichlet conditions. Here we can have the finite number of the discontinuities in the function within the given range. Our function must be continuous. So ultimately, what is the scene is that if we have the kind of the finite number of the discontinuity functions can be expressed in terms of continuous functions, and that is done by the Fourier series. Fourier transform is totally different than the Fourier series, so don't get confused with it. Here, the range over which the function is defined or the constraint is being provided. Okay, suppose that we have the function f of x and has the defined over the interval between the 0 to L, then this function can be expressed in terms of the sines and cosines, and sines and cosines are the continuous functions. So f of x is equal to a0 by 2 plus summation, which is run to infinity. We can have the an cos n pi x upon L plus bn sine n pi x upon L. Here we can have the a's and b's are the constants, and that we have to find it out. Okay, so here what is being asked that the find the value of the b2. Okay, find the value of b2. So the second elements in this expansion we have to, provided that our given function is a straight line with a unit slope in the range of the 0 to L. So how to solve this? We have to express our these coordinates in terms of the integrations. That is, a's are represented with the a0 is equal to 1 over pi 0 to 2 pi, and then f of x dx. Okay, so this is the function we need, and then we have the an 1 over pi 0 to 2 pi f of x into cos n pi x upon L into dx. Similarly, we can have the bn is equal to 1 over pi 0 to 2 pi f of x sine n pi x upon L into. If we look at the coordinates here, that is a's and b's, it is an integration defined over the given interval, and the function has been provided. If we look at our function type, whether it is an even function or the odd function, that will reduce our efforts to find out the components. Okay, suppose our function is odd, then all the a's or the an becomes a 0, or this integration gets vanishes because it is a multiplication of the f of x into cos. Cos itself is a even function. If I multiply with the odd function, whole function becomes so odd, and if it is defined over this interval, that automatically goes to the 0. So we don't need to find out the an. Similarly, so in this case, the bn survives. So this survives, and we have to find out the conditions for the bn. So we can have, now interval is 0 to L. So I just replace my range from, or the limits of the integration from the 0 to L instead of the 0 to 2 pi. So A0 is equal to 2 by L, 0 to L, and the function f of x is x. This will give rise to the 2 by L into x square by 2, 0 to L. So ultimately we'll get the A0 is equal to L. An I have already 0 because is a odd function. So Bn is equal to 2 by L, 0 to L, and the function x, and then the sign n pi x upon L into dx. Now this equation we have to solve it by the equation by parts, u into phi rule. So we apply the late rule, LIATE. The first function is logarithmic, then the integral function, then the algebraic function, trigonometric, and the exponential. So we have to rearrange the these functions according to this rule. So what is the integration rule for the u dot phi dx? So if you want to solve such a kind of integration, you must know the formula. Then only you could solve the problem. So answer is the first term as it is, integration of the second term minus integration of the derivative of the first term, I just represent with the u dash, into the integration of the second term, phi dx into dx. Okay, and try to solve it. 2 by L as it is, first term as it is, and then the sign, integration of the sign is a minus cos n pi x upon L into this L upon n pi. So I just divided with the L by n pi. Sorry, 1 meter. N, I just divided with the n pi. So L by np is the result minus integration and the derivative of the first term. That is 1 into this minus sign will make it plus sign into the sign.
Gaikwad sir,
Sorry.
sorry to disturb you. Right side of the right portion of your
Yes.
screen is not visible. Right page.
So, all right. Okay.
Now
Thank you.
it's okay. It's okay.
All right. Thank you. So here I just 2 by L and substitute the limits 0 to L. If I substitute the upper limit, then the L into L upon n pi minus this negative sign I keep here, then the cos n pi, because x will get, L will get cancelled with it, and this integration is a cos function defined over it, and that is a sine. So plus sine n pi x upon L into 1 over L upon n pi defined over the 0 to L. So this vanishes for the all n pi's. Sine is a 0 for the all pi's. Okay. So when I substitute the lower limit here as a 0, so that remains 0. So here I can have the 2 by L, and this cos n pi, it will give rise to the minus L square upon n pi into the minus 1 raised to n. So ultimately I would get the solution as the minus 2L upon n pi. And somewhere, okay, all right. So 2L upon n pi is the, so Bn, what I got it is the minus 2L upon n pi, and I have the a0 as a L. So the total function I can f of x is equal to x L by 2 plus summation n is equal to 1 to infinity minus 2L upon n pi into sine n pi x upon L. So the problem doesn't end here. We require the second term in the expansion. So the B2 term, because the B2 term we have to find out, means the coefficient corresponding to it. And that is coming out to be the, I guess, minus L upon pi, minus L upon pi, because 2 will get cancelled out for that case. B0, B1, B2. So just substitute the value here as a 2. So the 2L upon 2 pi. So 2 will get cancelled out. We can get the answer as a B2 is equal to minus L upon pi. There was again a question on the Fourier series. That is nothing but the state and explain the Fourier theorem. Means the earlier what I show about the Fourier series expansion as here as the f of x is equal to a0 by 2, and then the summation n is equal to 1 to infinity an cos term plus bn sin term, and define the these constants using the integrations. So this is a Fourier series expansion of it. And further it is being asked that, okay, if suppose f of x is instead of the x here earlier case, f of x is defined as some constant into 0, limits being provided here, x is less than 2 pi, not the, this is not the equality, is strictly less than 8. Okay, and being asked to find the series corresponding to the pi by 4. Sometimes it is being asked that, okay, show that the pi by 4 is equal to 1 plus 1 by 3 plus 1 by 5 plus all odd terms will be contributing at the denominator, and that will give rise to the pi by 4. I guess there is a alternate positive and negative sign must be there. Some mistake in the question probably. Because pi by 4 is 0.785, and it is being asked that it must be the 1 minus, then alternatively we can have the plus minus sign, so that we can reach to that particular value as a 0.785. Then moving ahead to the some complex problems. Okay, generally complex number is defined as z is equal to x plus iy, where x part is known as the real, plus we have the imaginary part. Okay, if suppose any number can be represented as a complex number, provided that okay, its imaginary part can sometimes be 0, sometimes can be a non-zero. If it is a non-zero, then okay, it is a complete complex number. Generally, we used to define. But any real number can be expressed as a complex number, provided its complex part is a 0. Okay, so here the x part represents a real part, and the y represents its imaginary part. We have to find out the coefficient of the I, not the I. Okay, so if I express this in terms of the exponential form, then r is equal z is equal to e raised to I theta. Here it can be defined over the circle. If I just can have this inclination with the theta with the radius r, I can define as this as xy is defined as r cos theta and r sin theta. So this can also be represented as r cos theta plus I sin theta. It can is a simple expansion of this. Okay. Now, if I can express my complex number in terms of the r cos r e raised to I theta or the r cos theta plus I sin theta, means the here exponential part gives us this angular inclination. Okay, initially how much angle it made with the its reference direction as x. Generally, this is the real part, and this is represented as the imaginary part of the complex number. Okay, suppose if I want to represent a number z with a unit vector e raised to I theta, we can have the cos theta plus I sin theta. If my imaginary part, real part is 0, means the cos theta becomes a 0, then I would have only the imaginary part. So this I can represent as e raised to, okay, this part becomes a 0, real part becomes a 0, so my z becomes a iy. So the theta becomes a I pi by 2. Theta becomes a pi by 2. So the my z or the complex number becomes a e raised to I pi by 2. So means z is I can express this I as a e raised to I pi by 2. Okay. Now if I just make the power of this I with the I, instead of the squaring it or the cubing it, instead of that I do the I raised to I. Then what is the nature of the complex number or that number, whether it will be real, whether it will be imaginary, or it is just the sum of the real part plus imaginary part, means non-zero, I mean to say that, or else whether we will get the only the non-zero number or whether we get the real part. So if you look at this number, initially it looks to be the like a complex raised to complex, probably the complex one. But if you try to replace this denominator, the base I, we raised e raised to I pi by 2. So I just do it I pi by 2 raised to I. We can have the multiplication of the powers. So e raised to I square pi by 2. Here we define that is a minus 1 is equal to I. If I square on the both sides, so I can have the minus 1 is equal to I square. So I just rewrite that is I square as a minus 1. So e raised to minus pi by 2. And this is a complete real number. So our answer must be a real part it. Okay, so the I raised to I is must be the a real one. Even if we have the multiplication with the 4 times, means the suppose I can have the 5i raised to 5i can also be written as I raised to 4i into I raised to I. It will give rise to the similar kind of the result as a real. So it must be in multiples of the 4 pi plus 1. So or 4n plus I raised to 4n plus 1 can give rise to the again the into I will give us the real result.
Dr. Shikuta sir,
Yes, sir.
can we take a break here? We can discuss if anybody has doubt, any question.
Yes,
It's
sir.
almost
Just
7:45.
yes, obviously, just one problem. It is little bit different than the what we study.
Yes, sir. Okay, okay, no problem, sir.
All right. So just one problem. Okay. Suppose I give you this one quadratic equation, quite familiar from our school days, childhood, I would say. 10x plus 31 is equal to 0. So this is a quadratic equation, and if suppose its solution or roots has been provided as 5 and x is equal to 8. Generally, we use the decimal system, decimal number system. Here, we want to find out that what is the what is the number system used for these roots. What could be our answer? What is the base of this given roots given so that this equation is satisfied? Generally, decimal systems, we just write down that is okay. Base is a decimal is a 10. So 10 into b is b. Hopefully everyone agrees. 10 to the base of the 10 is the same as the 10 because that is the base. Now, in case of the 31, what is it? 3 into base plus 1. Okay. So 31 to the base b, that is a 3 times b, means 3 into 10 plus 1 is the 31. Okay. If suppose this 5 and 8 are the single digit, right, and probably the highest value we get it b is greater than 8 because this is what we learn in case of the general number system. Suppose I want to express this roots in terms of my quadratic equation. So we can have the sum of the two roots, that is s is equal to sum of roots, and p I define as a product of roots. Okay. So sum becomes a 5 plus 8 as a 13, and roots becomes a 5 into product becomes a 40. So here I define that is a 10 to the 1 minute x square minus sum of the roots x plus product is equal to 0, right? So therefore I can write down 10 to the base b was b, means how much is the b in this case? that is sum of the product, sum of the roots, na 5 plus 8 is 13. And the next one is a 31b. That was defined to be the 3b plus 1. So this 31 is nothing but the 3b plus 1. What is b? We got it is a 13. So 3 into 13 plus 1, that becomes a 39 plus 1 becomes a 40. Okay. Looking back to the our solutions. Okay. So what is the sum between these two? That is 1 plus 5 plus 8, 13. And product becomes a 40. And this is being solved. So what we can have, the b is equal to 13 is the number system they use. Okay, so b is equal to 13 is the correct answer for it, or this is the base, we would say, in case of the numbering system they used. All right, so any questions, please? Yeah. Thank you for patiently listening.
No, ask for 3 questions and please conclude. Dr. Shinde.
Okay, sir. Any students have any doubt, any question? You can even type in a chat box also if you have any doubt.
Or raise hand.
Yeah, you can raise the hand.
Actually,
So,
lot many questions from orthogonal curvilinear coordinate systems that remain.
yes, sir,
I request
restricted
all
time.
our so because of time constraint, we cannot take all the questions that have been asked previously. But if as I have shared 3 question papers and their solutions earlier on this group. Once again, I am going to share all this. Even 23, 24, 24 and 25, these questions papers and all their answers will be shared by day or two, 1 or 2 days, that all. But our speaker has tried to attempt a lot many questions which have been very conceptual, that relate a lot of conceptual understanding of the concepts that we learn in mathematical method of physics. Of course, it is not possible at all to cover all the points or all the questions, all the concepts here in the lecture of 1.5 hours. Still, he has he has taken a lot of attempt to cover almost all questions. I request Dr. Sindhi sir, if there is anyone who is having some query, he can raise this query on this group only. Our experts or we all will try to explain or try to resolve that query there on the group only. So please go for conclusion now.
Okay, sir. Thank you so much, sir. So it was the first session in the NGPE bootcamp, and it was very wonderfully delivered by the Dr. Shri Krishna Gaikwad, sir. So sir is going to send you the PDF of all the solutions which he has taken all the questions in today's sessions, as well as he is going to share some of the solved problems along with the today's sessions, today problems. And he is going to solve problems and he is going to share the PDF on our WhatsApp group. So thank you, Shri Krishna Gaikwad, sir, for your time.
No,
And
my suggestion is,
yeah,
even if he is having some more problems, more conceptual problems,
yeah,
like the statements like refute, defute related to MMP,
yes.
or few conceptual questions, problems related to
Mhm.
MMP, mathematical method of physics, he can share all these things on the group. That will be helpful for our
Yes,
students
sir.
and everyone, if you have.
Yes, sir. So
Almost
I
all the
request
problems from the MMP has been covered.
So I
No,
request Gaikwad sir, if you have any left problems, any of the problems which has been left from your today's
Yes, sir.
session, you just solve those problems on a paper and you can share that PDF with the WhatsApp group.
even you can
Sure,
design
sir.
some new problems
Yes, sir.
Yes, sir.
on the
Yes, sir.
similar lines.
Definitely.
similar lines. That will be helpful for our students.
Yes, sir. Definitely, I'll do it.
And you can also add some tricky problems also, which can have a
Mhm.
very misleading answers. So you can please add those questions too.
Yes.
Yes, sir. Definitely. Yeah.
So
Because
we
there are
come to the,
a few mistakes in the NGP questions as well. So maybe I rectify them.
yes,
No,
sir.
no issue. No. You
So
can have your own problems, design your problems, get the
yeah.
solutions, and
Yes,
share
sir.
everything
Sure,
with
sure,
the
sure, sure.
students. Yeah, that will
Yes,
be
sir.
very helpful. Yeah, please.
Okay, so we are about to conclude this session. So I thank Rekha Gurpad ma'am, General Secretary of Central IIPT. I also thank the President, IIPT Sub-Regional Council, Pune. I also thank the former Secretary, Bharat Kangode sir. And also, I thank all the faculties who has been joined today's session. We have almost maximum 34 participants for the today's session. And also thank Dr. Sri Krishna Gaikwad sir for delivering numericals in mathematical methods in physics. So thank you everyone for attending the today's session. And tomorrow's session will be beginning with Professor Sunil Patil sir. He'll be taking some different problems from the mathematical methods in physics, and we'll start at immediately at 6:30 in tomorrow's session. So thank you everyone for your time, and have a good night. So thank you very much. I'm just closing the meeting now.
Thank you, sir.
Thank you, sir.
Thank you so much.